Hello everybody, Brad the Guitarologist here, and in this video we're going to take a look at this 1977 Ampeg VT-22 212 combo. I've had one of these before, and it's actually become one of my most popular videos. This, however, is the version 2 of this amplifier. The differences being this one has slightly less options as far as the tone shaping. You see the two switches right up above the tone knobs there, above the mid-range and the treble. The other version, the earlier version, had 4 of those, but it did not have a distortion control on volume 1. You'll see here we have 2 channels, 1 and 2. On channel 1 we have a volume control with distortion. On channel 2 we have volume, bass, mid-range, treble, reverb, and above the mid-range and treble we have the 2 switches which change the center point of the mid-range and treble pots. Also, we have lost our polarity switch over here because it's really not needed by this time. They started coming out with the 3-prong chords and they realized the polarity switches were just in excess. So we have a standby and a power switch only. The customer who owns this amp, it actually belongs to a church, and they said, the customer who brought it by said he's just having problems getting it to sound right, and it's just lost power and making lots of noise. So we're going to get in here. I'm assuming that the capacitors, all the electrolytics, are going to need to be replaced. But this will give us an opportunity to get inside one of these version 2 VT-22. So if that sounds like something you'd be interested in, please stick around. Okay, had to order new caps for this thing, and while we're waiting for those to arrive, let's take a look at the back of the amplifier. We'll zoom in here and see some of the features. First thing we notice that one of the original square back eminent speakers has been replaced with a Celestion 80. I've already checked the impedance on that, and that matches, so that's fine. We have an impedance selection switch all the way over here to the right, and the first thing I noticed whenever I got this was that it was selected at 4 ohms where it should have been 8 ohms, so they've probably been running this the wrong impedance for a long time. My guess is if it was in a church, that is the case, because usually in churches nobody even touches an amp but once a week. So we have an extension speaker out. There's our internal speaker out right there. We have a real nice cord wrap here. You can see that little piece of metal at the top there holding the cord. That's an extra cool feature. Keeps the cord from falling loose whenever you just kind of haphazardly wrap it up at the end of a show. We have a foot switch jack there, and the original foot switch is included. There's a hum balance pot hidden under there. There's also an effects loop hidden under there. I'll show you that. Here's our hum balance. Here's our effects, or actually, excuse me, that's a preamp out and a power amp in. We have an extra power receptacle over here with the 3rd prong, and we have a circuit breaker all the way over here. This amp has 7027s as power tubes. It has 4 of those, 12 DW7s, 112AX7, and a 6AN8. And the 6AN8 is in the phase inverter, and it's one of those triode pentode tubes. Oh, what's the matter, Ivy? What's the matter? Huh? Ivy doesn't like the 6AN8 pentode triode tube. Let's wait for our caps to come in, and then we'll get this thing up and going. Alright, here's the original 2-button foot switch that these come with. The earlier versions were kind of a puke green sort of a color, but this one is black. Not sure when they changed that. Also, over here, the holder for this foot switch, continuing the tradition of using some funky materials to hold the foot switch in their cabinets. It looks like Ampeg has used some kind of weather stripping material or something. They probably got a whole bunch of this stuff and said, what can we do with this? Okay, we'll use it for foot switch. It's pretty ingenious. It works. Let's see, what else? Oh yeah, these Ampegs in the 70s were a division of Magnavox, and Magnavox always had these tags in their equipment, and you see these also in their console stereos and things like that. But this one here is repeated on the cabinet, and it says there Ampeg at this point obviously was headquartered in Elkhart, Indiana, which is where Magnavox was headquartered at the time. I'm not sure what model 1102 is, unless that's like a specific model for this schematic. You know, it's like a schematic reference or something like that. But there's a serial number repeated and all the information. I'm not sure why they would have VT-22, but there you go. Maybe that's an internal Magnavox thing. But anyway, yeah, let's wait for the new caps to come in, and then we will get to repairing this big bad boy. Okay, new caps have arrived, and we're going to get these installed, and then we'll be able to see whatever else is wrong. Alright, we've gotten our first can out of the unit, and we're replacing it, and I just wanted to show you that this is an exact copy of the original, right down to the way that they labeled the can. They labeled it triangle, square, and half moon. Triangle, square, half moon, and they also correspond to the same value. So the 40 is the triangle, and the 100 is the half moon on the original. And on the new replacement, the 40 is also still the triangle, and the 100 is still the half moon. And what you want to do when you're installing these, I'm going to install it in the exact same orientation it was in as well, which means we're going to do it in this manner, and all we need to do here is just twist those leads that went up through there, or not the leads, but the tabs. We'll twist those sideways, and that will secure the can. Alright, there's the first can capacitor soldered in, and we actually had to bend those tabs over rather than twist, because they are constructed a little bit different than the originals. You can see these have these little feet on them, so that when you twist them, the feet kind of act as stoppers from this thing pulling back through. But on this one, the tabs are just solid, so you need to bend those over rather than twist. Alright, I have the second can soldered in, but as we can tell here, only one of these sections is used on this second 140, and the 100 is the one that's used. This one wasn't used originally. I'm also doing this for my own benefit, because this is the next one we have to take out, and I'm trying to just document where all these wires go. The blues go to the moon, so blue moon. Orange goes to the triangle. The square has a brown and a red, and we have a bunch of ground wires here. It looks like we have a brown and a gray. And over here we have what looks like a brown and a gray as well going to ground. Okay, we have all of the new caps installed. And dialing it up on the Variac right now, and I did the same thing last night, and I've been getting some pops and some noises, and I'll show you what I mean here. Alright, I've dialed it up just to the point where the lights start to come on and we start to get noise out of a speaker. And noise is about all we're getting, really. I can wiggle our tubes under here, and you can hear that. That is the pentode triode tube, which is microphonic as hell. That one's not too bad. All these sockets are really dirty. Looks like that first one is pretty microphonic also. But I think what we're going to need, and if you hear all this noise, it stops as soon as I pull this pentode triode tube. All sound stops. So what we're going to do, I'm going to dial this thing back down, and we're going to troubleshoot from here. Here's our suspected bad tube. It's a Magnavox labeled tube, so it's definitely the original one, I'm sure. It's a 6AN8A. According to the RCA manual, 6AN8A is a medium move triode and a sharp cutoff pentode. The diagram is 9DA. And in the back of the manual, it tells us right there 9DA pretty much has no 6-volt substitutes that we can choose from. I'm not sure what the 7060 or the 7258s are, but unless they're 6-volt, they're not going to do us any good. So we need to track down a 6AN8. So let's look in our tube stash and see if we can find one. All right. This is why it kind of helps to have a stash of tubes laying around. Oop, right there, look at that. First one I see. There's another one right there. So I've got, these are not rare tubes. I'm sure I've got more of these two sitting around. But we've got 2 to test out here, so let's check those. All right, here's the underside of the chassis, and we are dialing this thing back up on the Variac again. I have replaced the 6AN8 right here, and these plates actually are removable. I found this out when I made a video of one of these, the earlier version of this amplifier, and didn't realize that these plates would allow you access. I wasn't even thinking. But we have a couple of electrolytic capacitors under here. There's probably some more over here as well, I'm sure. We're going to replace before all is said and done. But for the moment, we're just going to see how it responds with the with this tube replaced. We'll dial it up a little bit. But yeah, there's 3 of them here that for sure will need to be replaced. We got some big power resistors there. A couple of other capacitors. Resistors all look okay. I don't see anything burnt or obviously wrong, but I do see where someone has been in here before. You see that? Right there. They've actually soldered around an existing resistor. What is that? R216? We'll have to look that one up on the schematic and see what that is. Let's see. I'm guessing that's for biasing. Well, we've dialed it up to about 80 volts or so on the input, and we're still getting some crackling and so forth. Still seems really microphonic. Maybe I've got another bad tube. Listen to that. That sounds to me like that's a bad capacitor. That's got to be a bad capacitor, or somebody has shorted something out in the process of tacking that on right there. Yeah, let's replace these capacitors and measure this, and also look up R216 and see what that is. Alright, here is R216, and as we can see, it's in the negative bias circuit, which makes sense that someone would try to change this to adjust the bias, but probably not in the way that they did it. I'm not really happy with the way that was tacked in. It's a big pain in the ass, but we're going to have to, set this thing up and try to solder on one side while we pull the part off on the other side. I mean, that's the only thing I don't like about these boards like this is they're pretty cumbersome when you're trying to work with the components to get them on and off boards like that. I just, I'd much prefer something, an eyelet board or something like that. Far superior as far as trying to work on something, but that's what we're going to have to do. We'll pull this off probably and start with the 39K and sort of go from there. And these caps, C207 and 208, are also those big caps surrounding R216, and those we are going to change as well. So let's get to that. Let's rebuild this, basically just rebuild this bias circuit right here, because if this isn't rock solid, everything else is going to be off down the line. So let's make sure our bias is rock solid first, and then we'll come back and do a measurement and see where we are as far as the bias, and go from there. Actually, before we go any further with that, here's the other side open as well, and we might as well take a look at this while we have the thing, before we flip it up on its side. Interesting components that they use in these. This is way more like a hi-fi system as far as the components, the style of components that is that they're using, like all these caps, these different plastic encased caps like these, and these guys here, you see these in Magnavox stuff, which by this time Ampeg was a Magnavox company, so that makes a little bit of sense. But look at all the different styles of caps and stuff they're using in this thing. Look at that. Look at that beast right there, that rainbow looking thing. Look at that. Interesting. A few of these. And I'm guessing they're color coded, but I'm not real familiar with these kinds of caps. Those are pretty. They look like bubble gum or something. Looks like you could just pick them up like a little chiclet, you know, a little bubble gum. Let's see. Well, one thing I did see right here. You see how close these components. I mean, that's a 5-watt resistor right there. And look what it's done to that. Look what it's done to that. Look at there. See, that was up so close. It's kind of melted that a little bit. So let's move that wire kind of out of the way, and also let's move this cap a little further away from it. That was right up next to each other, and it kind of shows too. Look how crispy that was. And these are concerning to me, L1, L2, and L3. We'll look up on the schematic and see what they are, but look, there's a bubble on this one. There's a big bubble on that one too. See that big bubble there? Let's look those up and see what those are. That might be part of our problem too, who knows. Alright, according to the schematic, L1, L2, and L3 are all three inductors. One's 800, 300, and 100. What's that? Microhenries, megahenries, whatever. Something henries. I'm not sure what scale that would be on. I don't see inductors very much in guitar amps, but here's where they are. Right here in the... this is in the switching circuit for the mid-range control and well, just the tone stack in general. Actually, I think that's all the mid-range control. Yeah, so those will handle your different mid-range settings. But this should be kind of a low voltage area. This isn't going to be something with a lot of high voltage attached to it. You got a capacitor right here, C12. If there is any voltage getting on this and messing things up, it would be from a faulty C12, or maybe a shorted tube or something like that, I guess. But yeah, these shouldn't see any voltages really to be concerned about. I think that might just be a manufacturing defect. But anyway, we will fix the rest of the amp, the bias circuit. We'll go ahead and do that and sort of go from there. Alright, here are the bias resistors that were tacked on to one another, pulled out of there, and in total they measure 28K. We're going to return this back to 39K just as a baseline, and then we'll kind of go from there. I mean, I'm just going to tack something in temporarily, and we'll measure until we get the correct thing. This would actually also be a good opportunity if we wanted to put in an adjustable bias, but I think after we get this biased in, these tubes are probably going to last long enough to not have to worry about it for a long time anyway, so We'll just leave it at a fixed bias, but we will change this resistor as necessary. One of the things you want to kind of look out for on some of these old amps like this, especially on these printed circuit boards, is the flux. All this old flux around some of these connections, like here you see this brown, dark brownish, almost reddish, blackish stuff on some of these connections. I've cleaned off a lot of this already, but in a lot of cases you will get piles of this stuff kind of bridging the gap between two connections that are not supposed to be connected. What you sometimes have to do is come in here with a tool. Oops. You have to come in here with a tool of some kind and just sort of scrape all of that excess stuff off of there, and then come back and spray it with some contact cleaner and clean all of it out. The reason you want to do that, because if you leave all of this old crystallized flux like this in here, what it can do is absorb moisture. It can kind of caramelize or carbonize over time, and if it's bridging the gap between two connections, you know, I think you can see what the problem might be with that. But you can see where it was on a lot of these connections. Actually, I've already come in here and again cleaned a bunch of these. This stuff was all over the place. If you back up the video to some of the earlier pictures of this board in particular, this had a lot of it on there. And I've gone through and scraped all of the the bridge connections so far. I'm going to get a toothbrush or something after this, I think, and try to clean up the rest of this crap and just kind of get it off there. So you know, if it does kind of absorb moisture or carbonize, it won't bridge connections at the very least. So that, you know, that's something to look out for on your own printed circuit board amps as well, especially if you're having intermittent troubles, or it sounds like something's wrong, or it's getting pops and you know, just weird noises. That can definitely be a cause. Alright, I just got a little bit of a shock here, and I wanted to show you what had happened. These two can caps over here, the outside housings are aluminum, as you probably have already seen in the video. But the ground wires for these, I assumed I had correct. Now this one over here, you know, I moved everything kind of over and grouped them together and twisted them together when I was changing this out to make sure I didn't mess anything up. But I must have done something wrong, because when I had this amplifier flipped over on the other side, I laid my hand across those two and kind of bridged, you know, from one to the other just absent-mindedly, and got a little bit of a shock there, and I was like, whoa, wait, what was that? And then got my tester out and tested between the two, and the potential between the casing on this one and the casing on this one was like 200 volts. So yeah, it wasn't dialed up all the way, so I'm glad. I would have gotten a little more of a jolt, but yeah, pretty interesting. All right, I think I figured out what I did. These two 100 at 450 volts, 100 microfarad capacitors. This is in one of the cans, and this is in the other can. This is in the can that's basically by itself on that one side of the chassis. This is the can that has the 40 with it. Well, if you'll see here, right past the rectifier, this is where our first filtering comes in, and these in series like this basically makes a 50 microfarad at 900 volts together. Alright, I have my leads hooked up just to the casing. You can see there it's on that tab, and this one is on the tab to the one next to it. So it's just on the outer casing of the two caps. I guess for dramatic effect I should have probably just flipped this chassis over and touched the leads to the outside of those cans, but you get the idea. It's the same thing. But look at this, still 250 volts, and this is actually, you know, it occurs to me, obviously there's still going to be 250 volts, because we're talking about the very center of those two 100s. You'll remember this 100 that's in this can and the 100 that's in this can, those are in series. They're wired up in series. So if you connect something to the center of those, which is obviously the negative of this 100, which is the casing for that can. You're going to get some voltage potential between that and ground. So yeah, that is actually a design flaw, I guess you could call it, of using these cans. But they got around that in the old days because the cans, if we look at the originals, they're covered in a cardboard. So what I think I'm going to try to do is maybe steam the cardboard sleeve off of this old one and slide it onto at least this one, if not this one and the other one, because, yeah, I mean, obviously, because... Alright, there's that can pulled from that sleeve, and that actually wasn't all that hard. You just grab the sleeve, you can push in from the top and then grab the can with some pliers and pull it out. You can see the adhesive they used. Good news is, the entire time I was getting this thing out, this thing has been running for a while, and everything seems perfect. I'll clean those boards. So there's no more, carbon or crystallized crap between any of these connections. A heck of a lot cleaner than it was. Changed all the caps, changed those bias caps, and I actually upped the values from 10 to 20 because I was out of 10s in that voltage, and 20 should still be okay in that position. And it's running pretty well. I mean, it's not dead quiet because I've got a fluorescent light overhead, but it is behaving properly. And I think all we really need to do now is put the sleeves on these cans and mark them as new cans. I don't want to just drop the sleeves on them and not at least mark this as a new can. The reason being, someone might come in after me and assume this is this is the original old can and replace it. So we don't want that. But let's go ahead and do that. But yeah, let this be a lesson to you, man. If you have an old amp like this, be very careful about reaching in the back and just willy-nilly touching on, these old can capacitors, or even the new ones, especially the new ones, if they've been changed out. Because none of these new ones have these sleeves like this, so they're exposed. So if you have a situation, and a lot of these old amps do have this situation, where you have two different caps in parallel like that, or excuse me, in series like that, you may have potential energy between one of them, the casing and the chassis. You might have potential energy between one can and the can right next to it. So if your hand bridges that gap, you're going to get a 250 volt jolt like I did a little earlier. So yeah, be mindful of that. Be very careful. And if you have replaced can capacitors, get your multimeter out and make sure there's no potential between the casings on those. One other thing I've noticed is that this standby light, it'll go into standby, but the light's not coming on. So that lamp is probably blown. I'll check that here in a minute to see. But these are, you can't just test these across the leads because these are neon, I think. Pretty sure that's neon light. Yeah, I'm positive it is actually. But yeah, I think I have a light like this. I'll check. But I think that light's bad. So yeah, it's time for the all-important tap test. I'm in input 1. And we'll just tap the end of a cord here to see if we're getting signal, and we are. Let's get some distortion on this sucker. Alright, so that's channel 1. Channel 1's okay. Let's try channel 2. Channel 2's okay. So yeah, I think we're good. Let's check that light, and let's also get those caps on the caps. And then we'll do some final checks here. I'll check the bias as well. I think it's going to be okay. Everything in the bias supply is okay, and those are the correct types of tubes, so I'm not anticipating any problems. But we'll go ahead and check the bias anyway, and then I think we're about ready to seal this thing up. So stay tuned for a demonstration. All right, here's the standby circuit. Here's the standby switch. It goes over here to a diode, and it also goes through the light. On the other side of the light, there's a 180K resistor R18 that's in series with it, and that is that resistor right there, R18, and R18 is dead. So let's replace R18 and see if our light comes on. I thought since I don't show too many amps like this with PC boards, I might as well show you what I do with removing a component like this. Make it a little easier, especially when we got both sides we have to deal with, both sides of this board. I'm going to use one of these tools. This is a pretty cool tool. It's like a little grappler. So we'll put that on the component, and that'll help us when we're having to reach around the other side and desolder. That'll help us where we're not having to look back and forth quite so much. Alright, one resistor later and we have a standby light that works. So that's cool. And looking at the outside here, the old covers for these can caps worked perfectly. And I just wrote on the outside of them in a magic marker on the back and turn them around, so you can't see it unless you take the chassis out and everything, that these are were installed and they're new underneath and the date. So if somebody comes in here, they won't think these are just the old ones. So yeah, I think all we have left to do, I've adjusted the hum balance, checked the bias. The bias was pretty much dead on, right around negative 30 volts or so. So we're good there. Let's see, what else? I think we're ready to, just about ready to button this thing up. We have a couple of microphonic tubes, in particular this one and this one. This is the one I changed before. This is the 6AN8, and I'm going to try a couple of other 6AN8s and probably get some new 12AX7s in here, clean the remainder of these pots. I cleaned this pot, but we need to clean the remainder. And I think we'll be ready to button this thing back up. So yeah, stay tuned for a demonstration. Alright, I had this thing all put back together and was about to give it a test, and we've got a lot of hum, really, more than I'm comfortable with. I don't know if you can hear that or not, but it's just kind of got some omnipresent hum, and it doesn't matter if stuff is if it's unplugged. I mean, that adds to it a little bit, but still getting some low-level hum even with volumes all the way down. And I've changed all the caps in this amp. They're all brand new. Everything's wired correctly. I've double checked it a couple times now, double and triple and quadruple checked it, and it's just noisy. I have noticed that when I tap on that 6AN8 tube, that it's real tinkly, real real microphonic. So I'm beginning to think that could be it, but I've replaced that now with what was a new old stock one, and it was the other one was doing the same thing. So I don't know if I've just got two bad tubes or what. So anyway, the troubleshooting continues.